Hey, how's it going, guys? It's Mr. Hill. Welcome back to another week full of asynchronous sessions. I hope you guys really enjoyed the activity that we did yesterday with our turtle and our distance versus time graphs. But now it is time to go ahead and take a look at patterns and how we can represent them with equations. So you might recognize a little bit of stuff from the previous few weeks, or maybe you won't at all, but either way, I think that you guys are really going to enjoy this chapter and everything that we're going to take a look at. So without further ado, let's go ahead and get down onto the iPad. So if we're going to take a look at this e-tool right here, this is the beginning, it's problem 2.1 for the chapter, and I want you guys to go ahead and take a second and open up your ebook, and I want you to go to section 2.1.1, okay? That way you can follow along. So what we're doing is, this whole section is titled, How Does It Grow? So we're going to see growth in linear relationships. And so by that, through the chapter, we will explore multiple representations of a linear relationship, and you're going to use the growth and starting value of linear relationships to find specific connections between situations, tables, graphs, and equations. The specific situation that we're going to work with today is the growth of tile patterns. So one last thing that we're going to do is we're going to take a look at our I can statement, or our challenge statement today, because our objective is for you to be able to write a linear equation that relates the number of the figure, so like the figure number or the stage number, to the number of tiles in a geometric pattern. So we're going to identify connections between the growth of a pattern, its starting value, and how we can represent that with a linear equation. So by the end of today, you should at least have a pretty solid idea in your head of how can I describe this pattern or this growth of a pattern using a linear equation. So without further ado, let's take a look at the e-tool. If we take a look here, we see that there's a figure 1, a figure 2, and a figure 3, right? So we got figure 1, figure 2, and figure 3. And taking a look at this, it looks like I've got one long side at the bottom that's staying put, and then it looks like we're just adding tiles on the left and the right side. So what do I notice when I look at the pattern? Well, figure 1 is a flat line with one tile on the right side. So it just kind of cuts across, and we got one tile here. Figure 2, I now have added one tile to the left side, and I added 2 more tiles to the right side. So that's how it changed from 1 to 2. And then if I look at figure 3, it looks like I've added another tile to the left and 2 more tiles to the right. So what I notice is as my figure number increases, I'm adding 1 tile to the left and I'm adding 2 tiles to the right. That's just what I notice. And I notice that like the bottom stays the same width. Like it's always it's always 6 tiles wide. It's always 6 tiles on that bottom side. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So there's always 6 tiles on the bottom. It's just that we are adding tiles on the right side and the left side. So if the left side is always growing by 1 and the right side's always growing by 2, part B says sketch the next figure in the sequence, so figure 4 for pattern A, on the resource page. You guys don't have to worry about it, just follow along with me. But then we're going to do figure 0, which is the name of the figure that comes before figure 1. So we're going to sketch figure 4 and figure 0. And I'm going to start with figure 4. So if I take a look, we already determined that I'm going to have 6 tiles across the bottom. So I know I'm going to have 1, 2, 3, 4, 5, 6 tiles across the bottom. And then we're growing, or we already have 2 more tiles on the top and the left. And I already have 1, 2, 3, 4, 5 tiles on the right. So I've already got that. But here's what happens. I need to know what changes. And so if from figure 1 to figure 2, we increase by 1 on the left and 2 on the right. And from figure 2 to figure 3, we increase by 1 on the left and by 2 on the right. Then I should probably keep that same pattern. So to change up the color real quick, we're going to add 1 on the left, and we're going to add 2 on the right. And that's what my figure 4 would look like. And then if we take a look at figure 0 and we try and sketch that, we got to think. So from figure 2 and going backwards to figure 1, we lost 2 tiles on the left and we lost 1 tile on the right. So my figure 0 is probably going from 1 to 0. If we go backwards, we're probably going to lose 1 tile on the left and lose 2 tiles on the right. And so if we were to try and draw a representation of that, we would wind up with just a line of 4 tiles, right? So for figure 0, I have 4 tiles. When I have figure 1, I added 1 to the left, and I actually wound up adding 2 tiles to the right. And then when I went to figure 2, I kept that same energy and added 1 tile to the left, 2 tiles to the right. From 2 to 3, I added 1 to the left and 2 to the right. In figure 4, I added 1 on the left and 2 on the right. So by how much is tile pattern A growing? Or like how many tiles is this pattern actually growing from 0 to 1, 1 to 2, and 2 to 3? Well, if you take a look, we started with 4 tiles for figure 0. So we had 4 tiles. For figure 1, I've got 7 tiles. Okay? For figure 2, I have 10 tiles. For figure 3, I had 13 tiles. And for figure 4, I've got 16 tiles. Count them all up. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if we make a table of values, where you have F is our figure number and T is our tiles. Let me go ahead and stretch that out. And we go ahead and write it in purple to change it up a little bit. When I have figure number 0, I have 4 tiles. Figure number 1 has 7 tiles. 2 has 10 tiles. 3 has 13 tiles. 4 has how many tiles, guys? You're right, it's 16. So there's our table of our values. So where are the tiles being added from each new figure? That's our next part for part C. So where are the tiles being added? Well, I'm adding 1 on the left and 2 on the right. So if we take a look at the representation for figure 4, you see that all of the blue tiles are what we already had from figure 3, and the pink tiles are what we added. So we're adding 1 tile to the left, and we're adding 2 tiles to the right. Now, here's the tricky one, part D. What would figure 100 look like for pattern A? And we're going to try and describe it in words. So my 100th one, if I want to think of that, I know that I've always got those 4 from the beginning. And I know that I've added 1 on the left and 2 on the right for figure 1. But if we take a look at figure 2, we know that I have my original 4, and then I've added 2 on the right and 4 on the left. So for figure 2, I added 2 on the left and 4 on the right. For figure 3, I have my original 4, but then my left side has 3 tiles, and my right side has 6 tiles. And for figure 4, I have the original 4 tiles from figure 0, right? But then I've added 4 tiles on the left, and I've added 8 tiles on the right. So for figure 4, I added 4 and 8. So it looks like our figure number has the number of tiles we have on the left, and our number of tiles on the right is 2 times that figure number. So 2 times the figure number gives me the number of tiles on the right, and 1 times the figure number gives me the number of tiles on the left. So our figure 100 would have 100 tiles on the left and 200 tiles on the right, with 4 tiles in between. That same 4, the 4 that we started with. So how many tiles would be in our 100th figure? Well, you have 100 tiles plus 200 tiles plus the 4 tiles in the middle. To me, that sounds like 304, doesn't it? So I would have 200 plus 100 plus 4. I had 304 tiles in total. So, part E, let's write an equation that relates the figure number x to the number of tiles y. So instead, if we look at our table, and we change f, or figure number, to be x, and number of tiles to be y, we see that as x increases by 1, our y value, or our number of tiles, increases by 3. So if x is 1, I've added 3. If it's figure 1, I added 3 tiles. If x is 2, I add 3. So I've added 3 more tiles, or 6 in total from our starting point, and so on and so forth. So every time the figure number increases, the number of tiles that I have increases by 3. But for figure 0, I started with 4 tiles. So I've always got those 4 tiles, and I'm adding 3 tiles per figure number. So if the figure number is represented by x in our equation and y is the number of tiles, my number of tiles y is equal to 4, the starting 4, right, plus 3 times our figure number, which is x. So x is figure number. And let's see if that checks out, okay? Are you ready? So for figure 0, that would be 3 times 0 plus 4 equals 4 tiles. For figure number 1, 3 times 1 plus 4 gives me 7 tiles. 3 times 2 plus 4 equals 10 tiles for figure 2. 3 times 3 plus 4 equals 13 tiles. And so if we take a look at when we plugged our values into this equation, it matches up perfectly with our table that we've already made. So we've now written our equation that relates the growth of this pattern, and what we're going to wind up exploring over the course of the rest of today is how we can describe patterns and how we can find starting values, or the rate in which we're growing, or like how many tiles we're adding per figure number, etc. So go ahead and start taking a look at the next few screens. If you need to, refer back to this video to take a look at everything I just told you, but go ahead and get a move on, guys.